All right, this is Mr. Wyrick. I'm just going to go through the semester exam review with you real quick, section by section. So the first section up here, name a line segment, or array. It's important to remember that all of these are going to be 2 capital letters. This one's a line, so I want to choose the symbol for a line with the arrows that go on forever. I can put any 2 letters in any order. So this could be BC, it could be CB, it could be CY, it could be YC, BY, YB. Any of those would be correct answers. Just make sure you have the right symbol over the top. And remember, you have to put both letters into each part, okay? Like very, very important that you don't, like, I saw a bunch of people put like 1 letter in 1 letter. That's not how this works. If you're gonna name them properly, you do have to have both letters in there to give it a name. So that's the line. The line segment is going to be both endpoints, and you should probably use the endpoints. When it comes to the ray, this is the tricky one. It doesn't matter that this ray actually goes from right to left. The ray arrow always goes left to right every single time, always, forever. And you always start with the endpoint. So both of these are going to start with I. Then I just name another letter that it goes through before it goes on forever. So this could be ray IO, it could be ray IE, and either one of those will be fine. So that's that whole section, pretty quick. The next section is interpreting markings on diagrams. This is just going to ask you about congruent angles, which would have the arcs on them, congruent segments, which will have the hash marks on them, parallel segments, which will have the little dart on them, and then perpendicular segments, which will be indicated by a right angle. Just need to make sure that you're looking at what it says. And remember that angles, it's important to use 3 letters. There's 2 angles. It could be W here, so VWP would be a good way. That's that. And then UTS will work for the other one. So UTS. Remember the symbols for angle, segment, all that kind of stuff, because that's how it's going to ask. Okay, next section, inverse, converse, and contrapositive. It's just going to give you a statement and then ask for which one is the converse, which one's the inverse, which one's the contrapositive. The converse is where you switch them. The inverse is where you add not to both of them. And then contrapositive, you're going to do both of those things. You're going to switch the order and you're going to add not. In this case, it's the converse. We can go to the beach if the weather, or if we can go to the beach, then it's good weather. Okay, and it has this on there, so you can kind of use that as a study guide, and it's nice. Coordinate distance using the Pythagorean theorem. This one asks you to draw in the triangle and go, okay, it's 1, 2, 3, and 1, 2, 3, 4, 5. So 3 squared plus 5 squared. It is gonna, it's gonna make me draw this. Okay, so draw in my triangle. There we are. I can answer the questions below. One leg is 3, the other one is 5. Remember the birthday cake method here if you need to. This is going to be 25 plus 9, which is 34. 34 splits into 2 and 17, and both of those are prime. So this one's just going to stay the square root of 34. Oh, they put it in the wrong place. The hypotenuse is the square root of 34. Okay, if you can reduce it, it will expect you to reduce it, but it's all going to be radicals. And just make sure you go back through the birthday cake method at some point. Simplifying radicals, same thing. We go through the birthday cake method. This one's going to be 2 square root of 2. If you need me to go back through the birthday cake method with you, we can do that. It's not a big deal. Midpoint formula, way too easy. 6 plus 1 is 7. If you cut that in half, that's 3.5. And then 7 plus 4 is 11. You cut that in half, that's 5.5. Oh, it gave me 2 sets of parentheses. I don't need 2 sets of parentheses. 3.5, 5.5, there it is. You add the x's together and divide by 2. You add the y's together, divide by 2. That's your midpoint. Finding angles in a transversal. Basically on this one, if they look the same, they are the same. If they don't look the same, they're going to be supplementary. They're going to add up to 180. So 180 minus 164 should be 16. And this is not really drawn to scale. But that's just how that one's going to go. Slopes of parallel and perpendicular lines shouldn't be too challenging. We do need to solve this one for y. That's going to be a -3 divided by a -5. That's 3/5. Perpendicular to that is going to be a -5/3. Remember, you don't have to have the x. A bunch of people missed this one first time because they tried to put x. Don't put the x. X is not part of the slope. Bisector, midpoint, vertex, whatever. Let's see. These angles are congruent. So IK is an angle bisector. And that's it. That's the only thing that we know for sure. Okay. It'll ask about stuff. So this one, TX, is a segment bisector. It goes right there. It's not an angle bisector. At least we can't tell the vertex of a pair of congruent angles. It doesn't say. Vertex of right angle, definitely not. X is the vertex of right angle, definitely not. So yeah, just make sure that you know what it's talking about if it's the bisector, the midpoint, or the vertex of a set of angles that would be congruent. Okay, the triangle inequality theorem. Which of the following sets of numbers could not represent the three sides of a triangle? Remember, any two sides need to add up to be more than the other one. So really, you just need to check the two small sides to make sure that they are more than the other. Otherwise, you have two sides of a triangle and it can't reach that third side. Okay, so that's going to be this one right here. 4 and 16 adds together to make 20, and 21 is bigger than that. That will not work to make a triangle. Be sure to check the questions. Some of them say which one could not represent a triangle. Some of them will say which one could represent a triangle. Any two numbers have to add together to be bigger than the third. Solve for the interior angle. Remember, the interior angles of a triangle add up to 180. So 180 minus 72 is 108. 108 minus 43 is going to be, I believe, 65. Yeah, there we go. So it's just they add up to 180. Not really that crazy of a thing. Properties of isosceles triangles. This is going to ask you about sides and angles of an isosceles triangle. Remember, two of the angles have to be the same. And in this one, this 155 is too big for another one to be that. Remember, they have to add up to 180. So 180 minus 155 should be 25. Yes, 25. So I have 25 between the other two angles. So each one is going to be 12 and a half. Okay, it may help to draw a picture. They show you the picture on here. I've turned off the penalties, so if you get one wrong, you know, pay attention to what's going on with these diagrams, the stuff that they're asking about, the stuff that they're showing you, the little guides, or just ask me during class. Triangle congruence, this is the side, angle, side, angle, side, 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 angle, side, and hypotenuse, leg are the acceptable ones. Angle is in there. Remember, that only proves that they are similar, not congruent. And remember, there's no donkeys in geometry. This one, though, is side, angle, side. The angle is between the two sides, so I can say, yes, this is side, angle, side. So the triangles can be proven congruent. Okay, and again, check. They have the stuff on here. They have some guides, I believe, if you get it wrong. When we have the similar triangles, remember that it's going to give us a measurement here. This is TR, it's 11. It goes from 53 to 69, so we're looking for WU on that one. We set this up as little over big, so it should be 10 over 27 equals 11 over X. We're going to cross multiply. We're going to find our answer there. Just trying to go quickly. If you need me to slow down on one of these, you can, of course, ask me during the class. Sorry, which segment is adjacent to angle L? Here's angle L, the one that's touching it. That's not my hypotenuse. This is my hypotenuse across from my 90-degree angle. So adjacent is going to be LZ. Definitely touching it. This is going to ask only about like opposite, adjacent, or hypotenuse. So which segment is the hypotenuse? It's the one across from the 90-degree angle. That's DY. Okay, nothing too crazy here. This semester exam's looking pretty good. Using trig to find a side, remember, you do need to make sure that your calculator is set to degrees. You can split screen this one with Desmos. This is going to be my opposite and my hypotenuse. I'll write SOHCAHTOA on the board again, but this would be the Opposite and hypotenuse would be sine. The sine of 43 is equal to x over 96. So 96 times the sine of 43. 96 times the sine of 43. I'm getting a negative number, which means I'm definitely in radians, not degrees. There it is, 65.47. Make sure you understand how to set these up. You can ask questions. Just trying to kind of refresh and get everybody a look at what it's going to look like. 65.5, I would say. Don't forget how to round. Don't want you missing stuff because you did it right. This is Pythagorean theorem again. It's the same as the distance on the other one. It's just asking you to find the third side. So this is 2 squared of 5 squared, which is going to be 2 squared is 4. The square root of 5 squared is 5. So that's 20. 20 squared, 20 minus 4 is 16. And the square root of 16 is going to be 4. Okay, so just work your way through it. Again, the problem types on this: find a leg, find the hypotenuse, find the leg, find the hypotenuse. And I believe on the test, I may have left it with these, where it's the integer or the unsimplifiable radical. I'm not real sure. But you should still be able to simplify them because that's what was on the other question. Lines of symmetry. This is going to give you a shape, and it's going to say, are there any lines of symmetry? Draw them in. So again, I'm kind of going like this. If I fold it in half on that line, it should be good. If I fold it in half on this line, it should be good. If I fold it in half on, click for me, there we go, that line, it should be good, and that should be everything. Okay, be careful on these. Do make sure that the pattern fits. Make sure that when you fold it, it would look the same. Check on your lines of symmetry. Identifying transformation. This is just, what does it take to make this turn into this? So the transformation here should be a reflection over the x-axis. And the fun thing about this one is it's going to animate it and show you slotting into place. This is the one that we did where there were some where it's like you would type it in and you would check. This is not going to be that way because it's a semester exam. So you do have to kind of know what's going on. Remember, the transformations are it's all rigid motion. So there's not going to be any dilation. It's just going to be you translated it over, you reflected it across a line, you rotated it some number of degrees. Congruence via rigid motions. It's talking about what is it going to take to make this one and then do this. So it's showing you what's happening here. So that first one appears to be a reflection across the x-axis because that's right there. And then this is 2, 1, and I'm taking it to 6, 3. That's going to be followed by a dilation by a scale factor of 3 because that's what I'm multiplying by. 2 times 3 makes 6, 1 times 3 makes 3. So that's going to put that in the right place. These are not congruent because there was a non-rigid motion. The dilation is the only non-rigid motion. So if you have a dilation, they're not going to be congruent because you used a non-rigid motion. If you only used rigid motions, if you only used the reflection, the translation, that stuff, then it's going to be congruent. There we go. Got it right. Who would have thought? Identifying quadrilaterals, you may need to go back. Remember, if the opposite sides are congruent, then that makes this a parallelogram. These are 90-degree angles, though, so that's going to make this one into a rectangle because it's equiangular. All the angles are the same. They are all 90 degrees. Remember, the quadrilaterals are going to add up to 360 unless we have something weird with the angles going on, and we don't have that here. This one's definitely going to be a rectangle. Okay, there's a bunch of these questions. There's 2 of these questions on the test. That's another rectangle. This one here, I was hoping to get something like this. This is just a generic quadrilateral. We don't have any indication that we have parallel lines here. We don't have any indication of anything else. All the sizes are different. No sides are congruent or parallel. So this is just a generic quadrilateral. And it has this. it has the categorization. So remember, quadrilaterals have 4 sides. Trapezoids are specific ones that have a pair of parallel sides. The parallelograms have 2 pairs of parallel sides, or opposite sides that are congruent, or opposite angles that are congruent, and stuff like that. Then we have the rectangles that specifically they have the right angles. We have the rhombuses where specifically all the sides are congruent, and the square is the overlap of the rectangle and the rhombus. It is both. Then we have the quadrilateral properties with the diagonals. I think there's only a couple kinds here. Yeah, we have the parallelogram diagonals. Remember, those are going to bisect each other. That's all that happens with the diagonals of a parallelogram. With a rectangle, the diagonals are going to be congruent. With the rhombus, the diagonals are going to intersect each other at a 90-degree angle. They are perpendicular bisectors. And then on the parallelogram diagonals with the angles, it's going to give you some kind of indication, something going on. STP is 96. It wants QTR. That's a vertical angle, so it should also be 96. Remember, any 2 angles next to each other on a straight line should add up to 180. And then the last question, or the last section here, so it will be the last question. It's the big one, right? We got a -9, -2, -7, -4, -3, -2, and then -5, 2. We graph that. It looks not great. We do all the slopes. We do all the lengths. Remember, you've already done length by this point on the test. You understand what a slope is. You put all of these in, and you're going to say that this one is a generic quadrilateral because none of the slopes and the lengths are going to match up. Okay? All right. If you have any other questions, of course, track me down. Come to me for tutorials. Hopefully you can try to get this done before you take your test, which tests, remember, are Wednesday, Thursday, Friday. The schedule, I've shared this with you. It is on Schoology. You'll be able to see it. And other than that, good luck.